Hey guys, welcome to Safi Mixed. In this video, I want to find the Laplace transform of a monomial linear function of the form f of t equals t. So from the definition of Laplace transform, the Laplace transform of this function is given by integral from 0 to infinity exponent minus st times the function f of t, which I write as t, and then this thing. Okay, I can solve this integral by I will use this definition. We know that integral exponent minus st dt is in fact equal to minus 1 over s exponent minus st, and obviously a constant if there are no limits, but we have limits, therefore we don't need to write a c over here. Nevertheless, if it is indefinite integral, we can write a c over there. So now we have the product of two functions and under this condition I can use integration by parts, and using integration by parts I can write this integral as first function. I'm taking this first function and the second function. So first function, integral of the second function is e minus st divided by minus s, and then integrated from 0 to infinity, then minus integral derivative of the first function, which is 1. I'm not writing that, and then integral of the second function is again exponent minus st divided by minus s, and then that dt. Okay, now let us look into this thing, what this gives. If I substitute, let me write this over here, t exponent minus st divide the minus s I'm writing over here in the denominator, so I can write this 0 to infinity, and I can write this as minus 1 over s into t divided by exponent st from 0 to infinity, and I can write it like this. Now I can split this for the upper and lower limit in the form minus 1 over s limit t tends to infinity exponent t tends to infinity t divided by exponent t, and then for the lower limit I can write this as minus limit t tends to 0 t divided by exponent st. So this limit, if I put this limit goes to 0, but this limit is in the form of infinity by infinity, so undeterminate form. Therefore I apply L'Hopital rule on this. In applying L'Hopital rule, I can write this as minus 1 over s into limit t tends to infinity. The derivative of numerator is 1 and the derivative of denominator is exponent st. And now if I put this is infinity, and now if I put the infinity, it gives me this gives me minus 1 over s into 1 over exponent infinity, and this obviously is equal to 0. So overall I can write this term as 0 because this term goes to 0 and this term goes after L'Hopital rule. So this term is in fact equal to 0. And now I rub this out and want to evaluate the rest of the part. So this minus with this minus will make it plus, and this 1 over s at its own place. So I write this as 1 over s integral from 0 to infinity exponent minus st dt, and now I can integrate this to get 1 over s into minus 1 over s into exponent minus st, and limit from 0 to infinity. I have this thing. So this minus taken out of the brackets, and s with s would make it square. So I write this as minus 1 over s square, and I put the limits, so it gives me exponent minus infinity minus exponent 0. This thing goes to 0 and this thing is 1, and this minus with this minus is plus, so we are left with 1 over a square. That is, the Laplace transform of the monomial linear function is 1 over a square. You can memorize this result. Thanks for watching.